Go, Collin.
Good job.
I imagine
What's that? I know you do. But you're different than most. Is that true?
No.
It is. That's okay. I know. It's like my neighbor has all of his thermostats set in Celsius. And that's great, right? But most people in the US do not.
Kilograms.
So, well, once we find out what room we're in, you guys should make sure you project your presentations to see how it looks. And if you guys want to do another practice round, regardless of whether we are available, you guys can get together and do it yourself. We can book the room for you guys, so
What room
let
are they
us
in?
know. We're not sure if we're going to do Tiggins or Hamilton yet. You ready?
That'll be nice.
Yeah.
Okay, next we have Collin1 talking about whether or not, or does parasitism alter predation rate?
Thank you, Kyla, for that beautiful intro. Hi, everybody. Like Kyla said, my name is Collin1, and I've been studying parasites here on Appledore Island for the last 9 weeks. And I'm looking at specifically, and we'll be sharing with you guys a question I looked at as to whether or not parasitism alters predation rates of organisms right here in the Gulf of Maine. So to begin, I want to bring everybody back to the 3rd grade science class and talk a little bit about food webs. As many of you may remember, food webs show the specific interactions between certain species, as well as the flow of energy through that system. And the typical lesson of teaching is the primary focus of the connectivity between primary producers, herbivores, and carnivores, and the relationships that they share. But historically, something has been overlooked in that picture. And that one something are parasites. So parasites are often left out of food web analyses in science, which is really interesting because some food webs themselves can have roughly 30% of named species on this planet have been identified as parasites, and some food webs contain more parasite-host relationships than predator-prey relationships. It's also important to note that some parasites require multiple hosts, so they have serious interaction with multiple organisms throughout food webs, not just one. And we do know that some may not directly kill their hosts. But what we do know is that some parasites alter host behavior. Previous studies have looked at how some infections can cause hosts to exhibit conspicuous behaviors that can change interactions between species. And for an example I'm going to share with you guys right now, this certain individual, after being parasitized, had increased predation rates by its avian predators. This is a snail that has been infected by a parasitic flatworm, and I'll play that right now. So what you guys are seeing here is this antenna. Actually, it's containing a sporocyst of a parasite. It's basically a vesicle that contains multiple parasites. And what's happening is you're seeing a physiological change of this antenna pulsating to draw in predators. So that's a physiological change, but not a behavioral change. The behavioral change that occurs with this snail after it's been infected is it will actually climb to higher points in vegetation to be exposed at greater rates to avian predators, which will then increase the dispersal of this parasite throughout the ecosystem. So it's a great benefit for the parasite, not so much for our host. Thanks, Jim. But what I was interested in is whether or not this parasite-host relationship exists here right in the Gulf of Maine with other organisms. I think that's it. Sorry, guys. So in order to study that question of whether or not this parasite-host relationship in trend is present here, I looked at the European green crab, also known as Crassinus manus. It is an invasive species that got here roughly 200 years ago on the hull of boats, and ever since then has had some serious impacts to native ecosystems because it is such an aggressive predator as well as a heavy feeder. One crab can get up to 40 clams a day, which can equate to about 15,000 a year. So they can have some serious negative impacts to the intertidal food webs. Additionally, it is a host of numerous parasite species, including Microphyllus similis. So I've created this illustration for you guys just to kind of give you a rough idea of what Microphyllus similis does in the food web here. So to begin, we have our first host, the snail over here, which will then graze over some gold poop that has, feces, some gold feces that has the parasite egg within it. The snail will then shed the parasite into the water column and infect the crab. From that point, the crab will then be preyed upon by gulls. The gulls will then digest the crab meat, and the parasite will sexually reproduce in the gut of the gull. It will then defecate out the parasite eggs, and the cycle will start all over again. And so what we do know about the relationship between Carcinus manus and the parasite Macrophyllus is that behavioral changes occur shortly after infection. So my mentor, Dr. April Blakesley at East Carolina University, studied these guys and found that they had decreased performance, and she measured this using writing response times. And so writing response basically is the amount of time it takes for a crab after being flipped over on its back to right itself. And I did a little bit of analysis here with my crabs as well, and I found that if you look here on my x-axis we have treatment, and on the y-axis we have mean flip time. My exposed crabs that were infected had significantly higher flip time than my control crabs. Additionally, April found when she was running this experiment that the infected crabs had longer prey handling times. And we do know that behavioral changes are not long lasting through experimental analysis, and found that Macrophyllus does not cause mortality. However, what we do not know, and what I'm looking at specifically, is how Macrophyllus affects the relationship between crabs and gulls. So I'm looking at whether or not parasitism increases the predation rate of Carcinus manus by shorebirds. In order to do so, I began here in Appledore by collecting parasitized snails. So I sampled 4 different sites in Maryland and did dissections to determine parasite prevalence in these 4 regions. I found that high tide dock here, circled in red, had the highest parasite prevalence, and collected snails from that location to infect my crabs with. This image right here is just showing some parasites, Macrophyllus that I found in one of the snail holes. And just to kind of give you an idea of how heavy these infections are, these larger sausage-like structures are actual parasite sporocysts that contain hundreds of parasites within them. So one snail acts as a parasite factory throughout its life cycle and can expel thousands into the ecosystem. Next, I ran some exposure trials infecting my crabs. So I had one tank that was my exposure tank that exposed green crabs to parasitized snails, and then a control tank that had unexposed crabs. And in my exposed tank, on the left, I had a number of individuals that I would be using to measure predation, and then I had a number of individuals that I would be dissecting. Now the reason why I had in my exposed tank individuals to dissect was because I wanted to ensure that these guys were actually going to be infected. And so what I had to do from there is I extract this orange tissue of hepatopancreas and look at it under the microscope and analyze and determine whether or not these parasites are going to be found. And I did find a very heavy parasite prevalence. If you look in the image on your left, those little circles, I know it's a little difficult to see, are metasecarious cysts of Macrophyllus in its early stages. And so I was able to determine that, yes, my exposure trials did indeed work. I was able to infect the crabs. Next, in order to measure predation, I performed tethering experiments. For those of you who are unaware what tethering experiments are, it requires you to basically put an animal on a leash and tie them out in a certain area at a fixed point. For this situation, I used the mid to lower intertidal, and I measured the crabs' predation rates over a period of 24 hours and 48 hours, and used standardized plots to ensure that each crab had equalized microhabitats. Now, for my results, if you look at this graph down here where you have treatment on the x-axis and the number of crabs on the y-axis. In the red, that's the number of individuals that were alive at that time period, and then in the black, that's the number of individuals that were not. And what I found was after 24 hours, more controls were consumed initially, which is actually the opposite of what I had hypothesized. However, after 48 hours, we see those levels, of predation rates equal out. And so this made me think, okay, why is this occurring? Because this is the complete opposite of what I had predicted. And after doing some thinking, I thought there could be connections to previous studies that my mentor, Dr. April Blakesley, has done. Like I had mentioned before, she found behavioral changes were not long-lasting in green crabs. And so I wanted to see if there's a connection between these behaviors that are not long-lasting and the leveling of predation rates after 48 hours. And so I ran, once again, some flip trials. To remind you guys, flip trials is when you put the crab on its back and it writes itself up. And what I found immediately after infection, Carcinus manus exhibited longer writing response times as opposed to crabs after 48 hours. And so if you look here at my graph, I don't even think I need to explain that. I should explain that first. Scratch that. So this could be a measure of increased performance and a possible rationale as to why I'm seeing equalized predation rates after 48 hours. And so what does this all mean in the grand scheme of things? So as a conclusion, Macrophyllus may actually reduce the predation rates of Carcinus manus. My thinking is that just like humans, when Carcinus manus is parasitized by Macrophyllus, The infection causes lethargic behavior, which we found in the past, and this could potentially reduce their exposure to predators because they're not out in the intertidal when the tide is coming in foraging, so they're not going to be seen by the predators, as opposed to the uninfected crabs. Similar trends have been seen in other studies that analyze parasite-host relationships between a mosquito and a parasitic flatworm. They found that the parasitized mosquito was eaten at lower rates than unparasitized mosquitoes because they didn't perform the same, I need to look at the word, but like wiggling behavior, which made them less notable to predators. And finally, behavioral changes that impact predation could be very short-lived. That's what I was representing in that last analysis between the flip time at right after infection and 48 hours after infection. And this could be a benefit for Microphyllosimilis because Microphyllosimilis, once it's infected the crab, requires an incubation period before it is mature enough to be able to sexually reproduce in the gull's gut. So if it's eaten right away after infection, the parasite's not going to be able to reproduce and then benefit the population. And so, why should we care? The most important point, I believe, is that what I mentioned earlier, some food webs contain more parasite-host relationships than predator-prey relationships. And given the fact that Carcinus manus is a booger and is extremely abundant in these areas, it's like a competitive species to native organisms and pushing those organisms out of their native ranges. And knowing the relationships between invasives, parasites, parasites and native populations helps us better understand food web fluctuations and population dynamics over long term. It's just my acknowledgements. Kyla, I totally spelled your name wrong. I'm so sorry.
Who's Kyla Bennett?
I don't know, honestly. I don't know what I was thinking, but yeah, so I know we don't have a lot of time, so if you guys have questions or science questions
You're
first.
at 10 minutes